we're starting chapter 9, but before we go to 9, we got to start in section 1.9. So going back to the beginning of the book, which we skipped, this is circles are part of conics, and we're going to put them there. So starting out with reminding you what the distance formula is, what the midpoint formula is. Those are going to usually be horizontal and vertical distances when we're dealing with circles, ellipses, hyperbolas, and parabolas. For today, um, we're just going to run through distance, midpoint, standard form, uh, center and radius when it's at the center and when it's not at the center. And then we're introducing the toughest part, and the part that's most fun is general form. We've got to remember how to complete the square. So we're going to jump right into this. The distance formula, if you remember, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's just the Pythagorean theorem. I'm going to let you work this, make sure you understand it. So let's pause the video and work it. All right, so the question I think you come up with, does it matter which one's 1 and which one's 2? And the answer is no, just be consistent. If this is 2, then it's always 2. If this is 2, then it's always 2. Just stay consistent. All right, midpoint formula just means taking the sum of the x's divided by 2 and the sum of the y's divided by 2. Don't make this harder than it has to be. I'm going to let you pause the video and work it. And again, just making sure you're plugging numbers in. It doesn't matter which one's 1 or which one's 2. Just be consistent with what you're doing. Jumping into circles specifically, got to start with the definition. A circle is a set of all points on a plane that are equidistant from a fixed point called the center. Fixed distance from the circle's center to any point on the circle is called the radius, which we all know, right? If that's the center, it doesn't matter, where you're going, the radii will all be equal. The standard form of an equation says x minus h squared plus y minus k squared equals r squared. Remember where h and k are the center. Always the opposite of h and k, and r is equal to your radius. I believe you've seen this before, but let's go through it anyway. Write the standard form of the equation of a circle with center at 0, 0 and radius 4. That's just simply x squared plus y squared equals 16, r squared. Okay, when it's no longer at the center of the circle, that's going to be x minus 5 squared plus y minus a negative 6 squared equals 100. And we have that in standard form. Now, you guys, we are going to put a general form later. Okay, number 5, find the center and radius of the circle, whose equation is, well, the center is negative 3, 1. So negative 3, 1, that puts it right there. The radius is equal to 2, right? It's a square root of 4. That means I can put points 2 units away from the center, and that will end up being your circle, right? And then when we graph this puppy, if I do this right, I'll have a nice perfect circle. See how perfect that is? All right, notice the radius is 2, and yes, I missed it a little bit, but that's life. Close enough, right? Use the graph to define the relations domain and range. The domain is from negative 5 to negative 1. Those are your x values. The range are your y values from negative 1 to 3. All right, the general form of the equation is written in this form. This is kind of interesting. In order to do this, I'm going to have to remind you briefly how to complete the square. So if you remember, if I start with x plus 5 quantity squared, we're going to multiply that and get x squared plus 5x plus 5x plus 25, x squared plus 10x plus 25. That's a 25, trust me. All right, so a couple of things I need you to notice here is that half this middle term squared will be this. So if I ask you to complete the square, for instance, let's say we had x squared plus 6x plus 32, let's make that minus 32, plus a negative 32, 32 equals 0. You would say x squared plus 6x plus something equals positive 32. And to complete the square, we'd take half this middle term squared, which is 9. If I add 9 here, I have to add 9 here, which gives me a perfect square over here. This is a perfect square. X plus 3 squared equals 41. So we're going through a process here where we're going to complete the square. Now, what happens if that has a 3x squared plus 8x plus something equals 15, right? Okay, well, I probably should have made this a 6, 12. Let's make it a 12, right? I want to pull out the 3's. So this is just an x squared plus 4x plus something equals 15. Half the middle term squared is 4. If I add 4 here, I have to add, well, it feels like 4, but it's actually 12 because you have to multiply that. The 3 got factored out. This now gives me a perfect square, x plus 2 squared equals 27, and we can work from there. That's a brief reminder of what completing the square is all about. We want to write the general form in standard form, which means we're going to complete the square twice, and I'll walk through this. I'm going to rewrite this as x squared plus 4x plus something plus y squared minus 4y plus something equals 1. Remember, I'm adding 1 to both sides here. Get rid of that 1. This allows me to complete the square. Half the middle term squared is 4, so plus 4. Half the middle term squared is again 4, so plus another 4. This is a perfect square of x plus 2 squared plus, this is a perfect square of y minus 2 squared equals 9. They didn't ask us to find it, but we now know that the center is negative 2, 2, and the radius is 3. So going from standard form to general form is what we're looking for. Good luck and have some fun with circles. Get good at it because we're moving on to ellipses, hyperbolas, and they are all going to consist of the same type of process.